morning. Let's talk about lesson 4 from unit 1. This one is a lot of opinion based. And let me tell you, stop Googling. These are responses in this lesson are your opinions and showing what you know about representing data and choosing the best chart to show your data. I don't care what ChatGPT says. I don't care what GWAFBath says. So let's talk about it. Starting with this table right here. There is so much information. We've got names, we've got shoe sizes, we've got height, we've got test scores. This looks like all the information you might have gathered in a survey, but this does not display data so that you can see trends. When we're displaying data in graphs and charts, we want to see the common things. We want to see comparing. We want to see contrast. Do a lot of people like peanut butter ice cream, or is it not very popular? Do we want to know that the older you are, the taller you are? I don't know. So let's take a look. Our first graph that we're going to look at is technically this would be called a dot plot or a scatter plot. And we can see here that there is a positive correlation. Let me see if I can grab my little drawing tool here. I've never used it before, but look, see how I draw a line? I'm not connecting the dots, I'm just getting close to them. And do you see how it looks like it's going up the mountain or up a slope? That's a positive correlation because it's going up. Now, what if it were going down the other way? What would that be called? Now, what are the odds I can figure out how to get this off my screen? I can erase it. Can y'all tell I've never used the drawing tools on this before? I haven't. I don't want to delete. How do I get rid of all of it? I have no idea. We're just going to leave it there. What if I turn off my pen tool? Get my cursor mode. Oh, cool. It stays up there. Sweet. Well, look at this. This one is a downward slope or a negative trend. Did you say that before? Did you say negative correlation? Then you would be right. Okay. Now, again, we're not looking at connecting all the dots, but it does make sense that the more TV you watch, you might make a lowered score on your test because you weren't studying for it. Maybe. Depends on the subject, right? But if we go back, the previous chart showed a positive correlation such that the taller you are, the bigger your shoe size. Okay? Now, normally on the x-axis, let me see if I can change colors. Do I get to change colors? Oh, look at that. So remember, this is normally my x-axis and this is my y. Now, write this in your notes. X is my independent. So usually we want to see our independent value on the bottom, the thing that we control. Now, I know we don't control our shoe size or our height really, but generally speaking, the thing that we're changing, okay, would go there. And the thing that depends on that would go on the other side. This one, because neither one is really an independent or dependent variable, that's the way they're here. Plus, it just makes sense to see height going up. We usually see time along the bottom because that's the constant. We don't change time. It's not, time doesn't change depending on the weather. Time doesn't change depending on our height. Time is time. Okay, those are independent. Either things we control or things that are constant. If that makes sense. So we put height on this side because it makes more sense for our brains to see it going up because height is going up. But height is not dependent on your shoe size. Generally speaking, the taller you are, the bigger your shoe size because you need bigger feet to support your body. So I would say that the shoe size is dependent on your height, normally speaking. So think about that when you're asked questions like that. And that's something you want to be looking for in your charts, in your questions, is where is the independent and the dependent variable? Time, if you're dealing with anything to time, that should be on the bottom, okay? Anything to do with height over time, weather over time, rain over time, time should be on the x-axis. That should be on the horizontal. Okay? Tip, tip, hint, hint. All right. Now, here's an example of a scatter plot that doesn't have a correlation. It's all over the place because let's think about it. Does your height have anything to do with the hours of TV that you watch? No, not really. At least it shouldn't. I mean, maybe if you're a toddler. So this is what we would call no correlation. Okay? So remember, this one is no correlation. We scroll back. This one is a negative correlation. And this one is this one's a positive correlation. Now, tip, for those of you that remember Algebra 1 and those who don't, or those that have like put it out of your memory because, ooh, I didn't like algebra, welcome to my class. I'm going to make sure you do not have a bad taste in your mouth for algebra, okay? It's okay if you don't get it, but as long as you know you can figure it out. That is my goal for you. These are the same words we use for slope. This is a positive slope. It is a positive correlation. Oop, I'm still on that. Let me change back to the cursor. This is a negative slope. It is a negative correlation. This is no slope. We don't really have, this is a no correlation. We don't have a no slope. So no correlation, but we don't have a no slope. Okay, that just means the dots are all over the place. All right, now we have a bar graph. Now, a bar graph and a pie chart are going to be used in similar situations. A bar graph is great for showing different categories of the same thing. Excellent for showing counts, okay? The difference between when you would want to use a bar graph versus a pie chart is when you want to show exact data. If somebody asks you, how many people liked vanilla ice cream? I could look at this bar graph and I could see 4. But if I were to put these in a pie chart, I have no idea. There's no numbers. Now, I can see looking at the pie chart that more people liked vanilla than chocolate. But I'm not quite sure who liked more, vanilla or strawberry. They're very close. But I could rank it as chocolate was the least, then peanut butter, and then a toss-up between vanilla and strawberry. But I don't really know. There's no numbers. So if I need actual data, a pie chart is not going to be my friend. If I need to know precisely a number, I want to use a bar graph. If I just need to rank something like in order, then a pie chart's going to be easier because I just need to see size and grouping. If we go back to our bar graph, we can see, oh, that's why we were confused between strawberry and vanilla, because they are the same. They're exactly the same. But I couldn't be real sure in the pie graph. So remember that, okay? Again, hint, hint to answering your questions. Now this next one, we have a line graph. Now, the biggest thing to remember with a line graph shows changes over time. Changes over time. Hint, hint, that should be in your notes. Now, notice, where is the time on my line graph? On the bottom. Remember we talked about that. It goes on the bottom. And then my temperature goes up this side. That's because the temperature is dependent on the time of the year and your hemisphere. This is a chart that's based on Dallas. So we can see that in June, July, and August, it's going to be hotter or warmer or a higher temperature than in January and December. But again, it is also Texas, so, I mean, this is general, right, y'all? We never know if it's going to be summer in October still. Fingers crossed that it's not. But you want to see on a line graph your months or your time on the x-axis. Time is your independent. Your temperature depends on your time. Independent time. Temperature depends on your time. Okay? So if you can put the variable on the bottom and take your other arm that you made a bar graph with and put it on top and say this depends on this because it's built on top, then you know you've got them in the right place. All right. Hopefully that helps you answer your questions because they are short answers. Make sure you're looking carefully at all of these things. Look at the two tables. Compare them. What do you see on one graph that you don't see on the other? Or one table that you don't see on the other? When you get down to the bar graphs, don't just tell me that this figure is hard to see because it's blurry. I know. Have you seen these guys? Now these are my blue light. I have on contacts. I'm blind, okay? I get that figure 4.8 blurs together, but use math. Why is 4.7 easier to read for math reasons, okay? Remember, all of these questions have both right and wrong answers, and the same answer can be both right and wrong depending on how you explain it. Okay, so remember what we talked about with pie graphs and bar charts. Same for this one. Sure is pretty, but does it tell you the information it's being asked? All right, happy mathing.